Hi, welcome to your video on division properties of exponents. You've already learned about multiplying, so we're going to now do dividing. So you will be able to divide powers with the same base and raise a quotient to a power. First question is, how do you divide powers with the same base? Very similar to multiplying, same kind of concept that you have going on. Here's the rules. First, you're going to subtract the exponents, and then the base stays the same. And then I will explain why that works here. If you expand this out, so 4 times 4 times 4 times 4 times 4 over 4 times 4 times 4. What's happening here is that these will cancel out, because when you have the same thing in the numerator and the denominator, they eliminate each other out, and you're left with 4 times 4, which would be 4 squared, and then that is obviously 16, but that's the reasoning behind the way it works the way it does. So knowing that, here is the algebraic way of saying that, and obviously a can't be 0. But then here's another example. We have x to the 4th over x to the 7th, and then you just subtract those exponents. So 4 minus 7 is x to the negative 3rd, and then we have to get rid of that negative, so it would be 1 over x to the 3rd. Is our final answer for that example. And the last example I have for you here is m squared times n to the 4th over m to the 5th times n to the 3rd. And you're just going to remember everything we do is with similar bases. So you're going to do the m's separately from the n's. So m squared over m to the 5th is m to the negative 3rd power, and then n to the 1st power, which we don't have to write a 1 in the exponents, but you can. I'm not going to. And then we have to simplify that negative 3 power that we have on that m, so it's going to be n over m to the 3rd, because this is 1 over m to the 3rd, and then we're multiplying by n, so we'll be left with the final answer of that. Next question is, how do I raise a quotient to a power? I will give you the rules first. There's a couple more steps in this one, but it's not too bad. First, you're going to raise the numerator to the power, whatever it is. Then you'll raise the denominator to that same power, and then you'll simplify from there. The algebraic form of that is a over b to the n equals a to the n over b to the n. And then, with this example, I can show you why this works. This is saying we have 3/5 times 3/5 times 3/5, which really is the same thing as saying 3 times 3 times 3 over 5 times 5 times 5, which is 3 to the 3rd, 5 to the 3rd, which is the reasoning behind why you can follow those rules. So let's do a couple practice ones here. This first one, x to the 4th over 5 to the 3rd power. We will be taking x to the 4th to the 3rd power and 5 to the 3rd power. And then you know the multiplication rules here, so x to the 12th power over 5 to the 3rd, which is 125. Last example for you is just a little bit trickier, because there are negative exponents involved. Just a couple more steps is all, really, but you're still following the same process. So here we go. We have 2x to the 6th power to the negative 3rd over y to the 4th to the negative 3rd power. And then you're just going chunk by chunk. So I'm going to distribute it out here just like I normally would. So I now have 2 to the negative 3rd, and then x to the negative 18th over y to the negative 12th. Now we need to get rid of all of those negatives, and so everything's 1 over whatever it was originally. So you're basically flip-flopping what is in the numerator and what is in the denominator, being they're all negatives. So we have our y to the 12th then goes in the numerator spot, then 2 to the 3rd and x to the 18th power. And then we just need to simplify this down. And 8x to the 18th power is our final answer. Your turn. 2 questions for you. Be sure to show your work, and then check in with me when you are done. The answers are listed for you here. If you have any questions, if you can't figure them out, be sure to ask in class. This is the end of your video. Thanks for watching. I look forward to working on this with you more. Have a great day.